All right, so for this first one, we have f plus g of x, which simply means that we're adding f of x plus g of x. So that would be 2x plus 3 plus negative x minus 8. So when we add these together, we're combining our like terms. And our final answer for part A would be x minus 5. All right, who had that for number for part A? That is a question on the quiz where you have an f and a g and you have to add them together. For part B, we have f minus g of 2. So we have to figure out what f of 2 is and subtract from that g of 2. So you're going to take that 2 and substitute it into your f function. So that's a number. And then you're subtracting from that what you get when you substitute the 2 into the g function. So 2 times 2 is 4, and 4 plus 3 is 7, minus, and then that's a negative 10. So 7 minus negative 10 is 7 plus 10. So your final answer is 17. Okay. For question 2, we're substituting this x minus 2 in for x. We're going to substitute it in 2 places. So that would be 2 times x squared plus 7 times x. We're going to substitute in an x minus 2. So what you want to remember, though, is when you square x minus 2, you have to FOIL that out or distribute it completely. So that would be x squared minus 2x plus 4. When you add your like terms together, which would be these two, your final answer would be x squared minus 4x plus 4, and then x minus 2. You're going to distribute 2, distribute 7. So that will give you 2x squared minus 8x plus 8 plus 7x minus 14. So when you combine your like terms, would be your x's and your constants. So that would be a negative x and a minus 6. All right, who had that? Yes. Right here. Because it told us to find, are you talking about this? Wait, what are you talking about? Are you talking about right here? Negative 2 times x is negative 2x. Negative 2. Right, because I'm multiplying x minus 2 times x minus 2. All right, so I'll give you a moment to copy that down because that will be on the test. And then the last thing we're going to talk about, and it'll be pretty quick, is example 1, because we skipped that on Wednesday. And that's how to identify even versus odd functions. And that's the only example we did not cover, and then we will be done. Anyone need more time to copy down the bell work? Okay, so even versus odd. I'll give you a moment to copy that down. Even is the same thing as y-axis symmetry. We talked about that on the last test. So for an even function, that means even has y-axis symmetry. We're going to replace x with negative x and see, is it the same? That's the question we're going to ask. Because after we replace x with negative x, if it's the same, then it's even. For an odd function, we replace x with negative x to see if it's opposite. So I kind of like to think odd, opposite, the two O's. Odd is opposite, even the same. An example of a graph that is even would be a parabola with a vertex on the y-axis. Because if you fold that graph, it's going to match up on the left and right side. And odd means if you rotate it 180 degrees, it's going to be the same. So in other words, if I take the graph and turn it upside down, it looks the same. All right, so I'll give you a minute to copy that down, and then we'll work through example 1, and we are done. For if it's the opposite, because we're getting ready to do example 1, you'll see that if we replace x with negative x, and every term flips, that means it's opposite and it's odd. So once we go through the examples, it'll probably make a little bit more sense. Does anybody need more time to copy this down? All right, let's go ahead and work through it then. So example 1, I'm going to try to fit it. Let's go ahead and copy down these 3. So again, we're going to replace the x with a negative x. Okay, so let's look at A. Let me zoom in here. So I'm just going to replace the x. I'm going to rewrite this function, and now I'm putting in a negative x. So when I take -1 to the power of 5, do you think it's +1 or -1? Negative. So that's going to make that negative flip that 2 to a negative. So this becomes -2 to x, -2x to the 5th. And then -3 times -x is +3. So let's look at the signs here. This one was positive. See how we had a +2? Now it's -2. And then I had a -3, and now it's a +3. So both signs are opposite. This function and this function are opposite signs. Every single term flipped, which means that this is an odd function. Yes.
I thought because both their exponents are odd that the x's wouldn't flip. Is that not what we're focusing on?
Yeah, that's exactly what I said. I said -1 to the power of 5 is -1. And then, so yeah, you just repeated what I said a different way.
So wouldn't that would have mean it wouldn't have changed?
So let's look at this again here. So we have -1 to the power of 5, which is -1. And then what is -1 times 2?
-2x.
So do you see how this changed?
Oh.
Because it was positive, and now it became negative. And then this was -3, and it became a +3. Both signs are opposite of the original function. So let's look at example B. So we have 3, and then I have x to the 4th plus x squared plus 2. And now let's put in our -x. Now when you take a -1 to the power of 4, both of these are going to switch, and these are going to become positive. So a +1 times 3 is 3. And this becomes a positive. So when you compare the function that we have now, when you compare this function to what we started with, is it the same? Is it completely the same, or is it opposite? It's the same, which means that this is even. This graph has symmetry with the y-axis. So what I'm looking at to see is after I put in the -x and I simplify it, is this function the same as the function that we started out with?
No, the other exponent was 5, and then we look at that.
So like if you take a -x, so if you take -1 to an odd power, it's going to be negative. But if you take -1 to an even power, it flips to a positive. The exponent tells you what's going to happen to the sign. Yep. And then for our last one, C, we have x squared minus 2 times x. So this first one, because that's 2, is this going to be positive or negative? Positive. But the second one has an exponent of 1, which is going to mean I'm multiplying -2 by -1, which is going to become positive. So when we look at this function and we compare it to what we started with, it's not an exact match. but it's also not opposite, because one stayed the same and one term flipped. So this is a neither. So in order for it to be odd, every term has to be opposite. And in order for it to be even, every term, it has to be a match. And if it's neither, that means you had a mixture. So I'm going to leave that there for you to finish out your notes. This is the end of the first piece of chapter 2. You have your quiz on Wednesday. You all have your study guides. The answer key was posted, so you can also check your study guide. And you should be able to do the entire study guide. Homework 8 is due on Tuesday, and homework 7 was due yesterday.